Welcome back to differential calculus class. So, in this class, I'll be teaching you how to derive differentials of functions. So, let's start. What do my differentials of function? So, let's assume we are given a function y equal f of x. So, how do we derive the differential of this function? You will recall that under derivative, if you have to derive derivatives of this function, we will simply say dy dx equal differentiation of this f of x with respect to x. This is what we say. This is derivative of y with respect to x. Okay. Now, differential, here, what we are trying to do under derivative is that we are trying to look at the total change in y when there is a unit change in x. Okay. So, assuming x variable changes by one, that is the unit. What will be the total change in y? Total change in y may be greater than 1, may be less than 1. So it depends on what happens. But in differentials, we are not looking at the effect of a unit change in x on y. We are looking at the effect of total change in x on y. For example, in reality, we will not have a unit change in x. It may be we have 2 unit change in x, 3 unit change in x, and more than that. But in derivative, we only look at the effect of a unit change in x on y. But in differentials, we are looking at the effect of total change in x on y. Say for instance, let's say we have the change in x is, let's say, 5. What will be the total change in y due to 5 unit change in x? So if that is the case, what we are looking for, so we are trying to find differential or the function. So now, how do we do that? So what we need to do is just to manipulate this derivative rule. Now, let's go here. If I want to find the total effect of the total change in x, how will I do that? What I need to do is just to cross multiply this, okay, by making dy the subject of the formula. In other words, I'm going to have dy equal change in this function, that is f of x dx, then multiply by dx. So this is what is called differential. Everything we have here is what we call differential. Differential of y with respect to x. So this same thing can be rewritten as just dy equals, if I use another notation for this, the function of x dx. If I use f prime of x, which is equivalent to what we have here, it's equivalent to this, then I now have multiplied by dx. So this is what is reversed to as differential of y with respect to x. Hope you are getting this. Okay. Now, let's take a look at some examples in order to clarify it. Now, let's assume we are asked, so example, or we like examples. Okay. So examples. So let's say we have find the differential differential dy of the function which function y equal 7x squared minus 5x squared, then we have plus 6x minus 3. So we are asked to find the differential of this function. So how do we do that? So it's very simple. We just apply the rule. Don't forget the derivative of this. The best way to find the differential is to first derive the derivative. Then you now make the y the subject of formula. Now let's find the derivative. So step 1 to find this. Step 1, you can just say find the derivative. Okay, of y with respect to x. So if we do that, so we are going to have the y dx equal. So we differentiate with respect to x. So we are going to have, when we differentiate this one, we are going to have 14x minus, we differentiate this. How do we get 14 here? 2 times 7. Then we have 14x. Then you subtract 1 from the power. Then we move to the second term. We have minus. We also multiply the power by the coefficient, that is 10. We have x. Then plus this. This is a linear function. So the definition of a linear function equals the coefficient of the relevant variable. So we have, when we differentiate this one, we are going to have 6. Since we have minus constant, this is a constant, so constant becomes 0, so we ignore it. Now, step 2. So here is the derivative of this function. So step 2, say make the y the subject of the formula. So if you have to make the y in the subject of formula, so if I call this one equation 1, okay, so in equation 1, okay, let me call equation 1. So we have to make the y the subject of formula. So the y here is our differential we are asked to derive. So now, making the y subject of formula here implies that we just need to cross multiply. So if we have the y, okay, the x, we say equal, so I can put this in bracket, 14x minus 10x plus 6, okay, so we said you can say over 1. So how do we make this subject formula? So we just need to cross multiply. So by the time we cross multiply, we're going to make the y the subject formula. In other words, I have the y multiplied by 1, so I have the y equals then the x multiplied by everything I have in this bracket. So I have 14x minus 10x plus 6 dx. So this is the differential of this function we are asked to calculate. Hope you understand this. Okay. Let's take a look at another example. So let's take a look at another example. So let's also assume we are asked to find the derivative of this particular function. So let's say we are asked to find the derivative. Let's look at another example. Let's say we are asked to find the differential of another function. Let's say we have the function, let's say y equals 11x plus 9. This is the chain rule. We are going to apply a chain rule here. This is a function of function. So let's say we are asked to find the differential dy. So we want to find the y. So how do we find that? How do we find the y? So it's very simple. So solution. So don't forget the first step is to find the derivative that is define the derivative of y with respect to x. So if we apply chain rule to this, so we are going to have dy dx being equals to, in applying chain rule, what do? You bring down the power. So we have 3, then we have 11 x plus 9. Then we subtract 1 from the power, we have square. So we won't stop there. We now say multiply by what we have in the bracket, we differentiate with respect to x. So this is a linear function. So when we differentiate this, we are going to have 11. Therefore, this is equal to 11 times 3. So we have 33, 11x plus 9. This is good. This is the derivative. Now, step 2. What do? We find, or we make dy the subject of the formula. So why do we make dy the subject formula? It's because it is dy that represents our differential that we are trying to find. Now, we have in this equation we make dy subject formula. So let me write this. If I call this one equation 1, don't forget this is dy dx. If I call this equation 1, okay, in equation 1. So if I have dy dx equals 33 11x plus 9 squared. So if I make dy as a formula here, I'm going to have dy. I'll just cross multiply. If I assume this is over 1, so I'm just going to cross multiply to get my dy. My dy equals to dy times 1 dy. Then we have what we have here multiplied by x. The x we now have the x multiplied by 33 into bracket 11x plus 9 everything squared. So I have 33. Okay, so I have 11x plus 9, then I have square, then I put the x in. This represents the differential of this function. Now, let me give you some questions to try. So maybe 2 questions to try on your own to test your understanding of this concept of differential of function. So let's assume you have this. So you have to try this. So let's assume you have what is it called? Let's assume you have y equal to, let's say 2x raised to the power 3 plus 5x squared minus 3x, and you are asked to find the differential dy. Let's also assume that you have another question. Let's say you have y equals x squared plus x, and you are asked to find differential dy. So try it and drop your answer in the comment section. Thank you. See you in the next video.